everyone, this is Shramani Kadumkondla. Today I am going to explain about impulse response and step response. First, Chapter 1, Foundations of Signals and Systems. It is the understanding the fundamental building blocks of a signal processing and system analysis. Definition. What definition for signal? A signal is a mathematical function that conveys information about the behavior or attributes of a physical phenomenon. Common examples for the signal is voltage variations in electrical circuits, sound waves and audio frequencies, temperature fluctuations over time. Classification of a signals are two types. Signals can be characterized as continuous time x of t or a discrete time x of n based on their domains. Here we can see the continuous time x of t wave is this. The wave is in the continuous form. In a discrete, the signal is fluctuating. It is not continuous, so we can call it as discrete time x of n. What is a system? Input signal x of t or x of n, the signal fed into the system for processing. System processing, mathematical or a physical transformation applied to the input signal. Output signal y of t or y of n, the processed result containing the desired information. Here x of t or x of n are input signals and y of t or y of n are output signals. So the system will process the input signal and gives the output. It processes in the form of mathematical or a physical transformation. System can be linear or a non-linear. It can be time variant or a time invariant. It is a causal or a non-causal, stable or unstable. Examples for the system is electrical circuits, mechanical systems, digital filters and communication networks. Chapter 2, Testing signals. It is divided into two types: input and output, impulse and step. It is essential for mathematical tools for system analysis and characterization. The unit impulse signal delta of t. The mathematical properties of the unit impulse signal is it has infinite high amplitude at t is equals to 0. It has zero duration at instantaneous. Unit area under the curve. It is also known as Dirac delta function in a continuous time system, representing as ideal instantaneous event. System testing. It is used to probe and analyze system behavior by providing instantaneous input energy. The unit impulse signal it has mathematical properties, means it has infinite high amplitude at t is equals to 0. It has a unit area under the curve. Next, the unit step signal u of t. At t less than 0, signal value is equals to 0. The system is off or inactive. At t is equals to 0, discontinuous jump, sudden switching occurs. T greater than or equals to 0, signal value is equals to 1, then the system is on or activated. So here we can see that at t is equals to 0, system value is 0, means system is off or inactive. At t is equals to 0, there is a sudden change in a signal occurs. At t greater than or equals to 0, the system is on and active. The unit step signal represents sudden activation or a switching behavior in a system. Unlike the impulse step signals are arrays to generate physically using switches, making them practical for a laboratory testing and real world applications. Here we can see that the unit step signal u of t, y axis contains h of t, at x is equals to 0, the system is off. At t greater, here we can see that at t greater than or equals to 0, the system is on, means the graph showing that the system is active. Next, visual comparison between impulse or step signals, unit impulse, unit step. Here we can see that in a unit impulse, instantaneous spike at t is equals to 0. Here we can see that there is a signal like a dot. It has infinite amplitude and 0 width. Area under curve is equals to 0. Models in instantaneous events. In unit step signals u of t, it discontinuous jump at t is equals to 0. 0 for t, here we can see that at t less than 0, the graph showing that 0. For t greater than or equals to 0, the graph showing the peak value at 1. It also representing switching actions and practical for system testing. Next, chapter 3, impulse response h of t, the key to understanding linear time invariant system behavior. It is also called as LTI system behavior. Definition of impulse response: system input. Apply unit impulse t as input to the system under the analysis. System processing. The linear time invariant system processes the input impulse according to its transfer characteristics. Output response. The resulting output h of t is called the impulse response of the system. System characterization. H of t completely characterizes the linear time invariant system's behavior for any input. So here we can predict the system output for any input using convolution is y of t is equals to h of t star y of t is equals to x of t star h of t. So here x of t is the system's input, h of t is the system's processing, and h of t is y of t is the output response. Thank you for watching my video.